Welcome to The Explainer. Today, we're diving into something that literally every developer has to face, especially if you're a junior dev sweating over your very first CI/CD pipeline. And honestly, almost nobody gets it right on the first try. We're talking about testing strategies in continuous integration. We're going to look way beyond just writing code and really focus on the strategy layer that makes a pipeline actually trustworthy. We'll break down unit, integration, contract, and E2E tests, exactly what they do, and how to combine them so you never accidentally break your application. Okay, let's just dive right into this incredibly relatable nightmare scenario. Picture this. You just pushed your first big feature. You check your GitHub Actions pipeline, and it's this beautiful bright green. You've got 97% test coverage. Every single unit test passed flawlessly. So you deploy to production. And then your Slack absolutely blows up. 9 minutes of production downtime. Why? Well, because the database schema changed, and not a single test caught it. Your unit tests mocked the database. So when the real database schema was altered, every mock in your test suite returned data that no longer matched reality. The tests weren't wrong, They were just testing the wrong thing at the wrong layer. See, coverage measures what lines of code ran. It definitely does not measure whether your app works when it's actually connected to real infrastructure. So, how do we fix this false confidence? We look to a really powerful conceptual framework called the test pyramid. Originally coined by Mike Cohn, and honestly validated by a decade of incredibly painful production incidents, this pyramid maps out 4 distinct layers of tests. Each layer has a completely different scope, speed, and cost, and they're designed to catch highly specific failure modes. The shape of the pyramid itself literally tells you exactly how many of each test you need to write. You need a super wide base and a narrow top. That ensures that different bugs are caught by entirely different levels of filtration.
Now, what's really interesting here is this side-by-side comparison. It totally proves why we structure our tests this way. Down at that wide base, we've got unit tests. You're going to have hundreds of these. They're lightning fast, they use mocks, and they're perfect for catching business logic errors. Moving up a level, we hit integration tests. You'll probably have dozens of these. They run at a medium speed, use a real database, and catch those nasty schema or configuration bugs. Then, contract tests, also medium speed, using a test server to catch API boundary breaks. And finally, sitting way up at that very narrow top, end-to-end or E2E tests. You'll only have a handful of these because, frankly, they're slow. They require a full deployed environment, and they exist solely to catch complete user flow regressions.
All right, part 1, unit versus integration. This is all about our foundation, isolating logic versus touching real live infrastructure.
Let's really contrast these two. Unit tests look at one single unit of business logic, like one function or class, in total isolation. Everything external, it gets replaced with a mock, which is just a fake, programmable stand-in. In our source example, a whole suite of unit tests executes in just 0.04 seconds. That's pure logic, instantly verifiable. But remember our nightmare scenario? If you rename a database table from subscriptions to user_subs, a mock isn't going to care at all. It just returns what you told it to return. And that right there is exactly why we need integration tests. These tests use real infrastructure. We're talking spinning up a real Postgres database using GitHub Actions service containers or Docker Compose. Sure, they take a bit longer, maybe 2 minutes to execute, but they catch the exact class of bug from our cold open, that sneaky schema mismatch, or the missing database migration. Now, here is a crucial pro tip for you. Integration tests absolutely must be reliable. Because they touch real infrastructure, the #1 rookie mistake developers make is sharing state between tests. You always have to wipe that database state before and after each integration test. You do this using a clean state fixture. Basically, it runs a delete from SQL command before the test to ensure a fresh start, and then again after the test, clean up for the next one. Without both of those steps, your tests become order-dependent, and you'll run into that incredibly frustrating situation where a test passes locally but randomly fails in CI. No way we want that. So if you're a junior dev sitting there deciding what kind of test to write right now, just use this simple checklist. Ask yourself, does this need a database? If yes, boom, write an integration test. Is it testing pure code logic and edge cases? Write a unit test and use a mock. Does it test the boundary between 2 microservices? That's a contract test. And finally, if you're thinking about writing a massive end-to-end test, pause and ask yourself, can I just make this an integration test instead? If the answer is yes, absolutely do it. Integration tests give you way faster feedback and much clearer failure messages.
Moving right along to section 2, contract and E2E tests. This is where we protect our service boundaries.
Contract tests are actually super fascinating. You know microservices communicate over APIs, right? Well, imagine a video service that calls a subscription service just to check if a user is actually allowed to watch a video. It expects a JSON response with a specific field. Let's say it's a Boolean called entitled. But what if the subscription team refactors their code and accidentally renames entitled to is_entitled? Bam! The video service completely breaks in production. Contract tests, specifically consumer-driven contract tests, prevent this exact thing. The consumer defines the API shape they expect, and the provider runs a test in their CI pipeline to literally prove they deliver exactly that shape. If the field gets renamed, the contract test fails, and that broken API is completely blocked from deploying. It's a real game changer.
And honestly, that beautifully illustrates why we desperately need the very top of our pyramid, end-to-end tests. Look, these tests are the most expensive, they're the slowest, and they're definitely the most brittle. But, and this is a big but, they are the only ones that catch integration bugs, where perfectly correct individually verified components are just wired together incorrectly. So to keep your CI pipeline healthy, you've got to follow these strict rules for E2E tests. Keep the count low. We're talking strictly between 5 to 20 critical flows. Don't try to test every single permutation. Test what a user actually does, not what the developer built. And critically, these must run against a real live staging deployment, not just your local test runner.
All right, part 3, the CI pipeline workflow. Let's wire this whole thing together. So how do all 4 of these isolated concepts actually fit into a single, bulletproof GitHub Actions pipeline? Well, the answer maps perfectly to the speed and cost of each layer. Fast things run early, expensive things run late. Track this chronological pipeline with me for a second and watch how it levels up at each stage. First, unit tests run on every single push in about 12 seconds. If those pass, we step up and trigger integration tests using service containers, which take about 2 minutes. If the API changed, contract tests jump in and run in about 30 seconds. If all of those pass and we merge to the main branch, we build our image and deploy it to a staging environment. That takes maybe a minute. Finally, against that live staging environment, our 5-minute E2E user flows run. The rule is absolutely nothing deploys to the next environment until the layer before it completely passes. Which brings us to the absolute golden rule of CI testing. You only deploy to production after your end-to-end tests pass against the staging environment, never, ever before. The production job has to run the exact same Docker image. I'm talking the exact same code package and SHA hash that was built, tested, scanned, and validated against staging by those E2E tests. Your E2E test acts as the ultimate gatekeeper, running against a real staging URL to completely block a failing image from ever reaching your users in production. Now, to optimize your total pipeline duration and keep those developer feedback loops nice and tight, you really have to identify your execution bottlenecks. Just look at the massive difference in execution times here. Fractions of a second for unit, a couple of minutes for integration, and 5 whole minutes for E2E. This visual perfectly proves why fast tests have to run early and expensive tests absolutely must run late. Think about it. If you have a basic logic bug, you want the pipeline to fail in 0.04 seconds so the developer can just fix it instantly. You absolutely do not want to wait 5 minutes for an E2E test to time out just to discover a silly typo in your business logic. I want to leave you with a bit of a provocative thought to really challenge your current CI setup. If you went into your codebase right now today and renamed a critical database table, which layer of your CI pipeline would actually block that deployment from taking down production? Think about it. If your answer relies entirely on unit tests and mocks, well, it might be time to start building out your test pyramid. Implement those integration tests for infrastructure reality, contract tests for service boundaries, and E2E tests for genuine user confidence. Each layer catches what the others simply can't. Thanks so much for joining this explainer, and we will catch you in the next one.